Okay, so there's a skill that we're going to talk about, and it's called completing the square. So we want to make a trinomial that is we call a perfect square trinomial. And again, it's just a skill. It has a couple applications. Today, we're just going to practice the skill. Then we'll use the application later. So it means like if I have, this is a binomial, right, because it has two terms, I'm going to be able to add a third term to this to make it a perfect square. And if we think of numbers, this number is a perfect square. Why? Because when I can write it as something squared. I can write 25 as 5 squared. 36 I can write as 6 squared. So these are called perfect squares. So now we're going to make this a perfect square trinomial. And what that means is I should be able to write it as something squared. So I want to add a number here, a constant. You know, maybe it's 12, maybe it's 10. But whatever I add there is going to allow me to rewrite this differently as something squared. So we're going to focus on this one right here, x squared plus 6x, and we want to make it a perfect square by adding something. So we can add any constant to do this. So again, for something to be a perfect square, it means I can write it as something squared. And this trinomials will always be written as binomials squared. So it's going to be two terms. And again, there's some number I have to put in here that when I multiply it out, I'm going to arrive at a trinomial that starts off like this. Okay, so that's why I know I'm going to write it like this so I can multiply it out. I know it's going to be x and x because that's how I get the x squared part. So it's going to start off like that. This middle part has to come from when I do the x times whatever this number is and then the number times the x. They have to add to 6. Now here's the interesting part. They have to be the same number, because it started from this thing squared. So whatever number goes right here is going to appear in both spots here. So that number is going to be 3. Why? Because if I go x times 3, I get 3x. Let's do the x times x part first. Sorry, x times x, I start off with x squared. Then I do x times 3. I'm just doing, FOIL or distributive property. I get 3x. Now I do 3 times x. I get plus another 3x. Right? So then the 3x plus the 3x becomes 6x. So we can always decide what this number is going to be by cutting this middle number here, just the number, and actually the sign too, but not the x. If I take the number in front and I cut it in half, positive 6 divided by 2 equals 3. That's how I can decide the number that goes in here. And then that will help me decide what number's here, because then when I think about multiplying it out, I go 3 times 3. I get 9, right? So then we have to square this number. So remember that we have ax squared plus bx plus c. I don't know if you've seen this yet, but we call this b. So we call these a, b, and c when it's in this format. So the formula is b over 2 squared if you want a formula. That's how we find that. That's how we find our C. So that's a formula. But I like more understanding what's happening. Whatever this middle term is, you got to split it in half. And that's how you get your number that goes in here. And then how do you get the C? You have to square it, because remember it's going to be 3 times 3 in this last part of distributive property. So again, I'm just saying here that it's a skill that can be used in a couple different applications. First, let's just practice the skill. So I think of this as I want to make it a perfect square, which means I can write it as something squared. So I think of it like this. I know to get the x squared part, I've got to have x and I've got to have x. Right? So that's going to have to be an x. How am I going to get the plus 12x? I got to divide the 12 in half. So it would be plus 6 plus 6. So that means that's a plus 6. The reason I have you write it out like this is because then you can see that to get the last part here, I would have to do the last times the last. That's the last part of FOIL. So 6 times 6 is 36. That makes it a perfect square trinomial, because this trinomial can be rewritten as this binomial squared. That's why it's a perfect square, because I can rewrite it like that. And that's what a perfect square is. Remember, 49 can be written as 7 squared. So we're taking this trinomial and writing it as a binomial squared. The formula says that, remember, this is called C, or I'll write it above here. This is B, This is C, and then A is this guy, which in this case is 1. The formula says C is going to be equal to half of B and then square it. So if I take the positive 12 and cut it in half, you get 6. 6 squared is 36. So that's the way you can do it by the formula. If we look at this next one, C equals B over 2 squared. Let's use the formula. I take the B, and the sign matters, the plus 10. I cut it in half, I get 5, and then I square it. 5 times 5 is 25. That's called completing the square. I add this number, and it now makes this a perfect square. Let's do it here. C equals B over 2 squared. So negative 24. So you got to take the negative. C equals negative 24 over 2 squared. So negative 24 over 2 is negative 12. And then negative 12 squared is 144. So I add 144. Notice I'm always adding it. That's because the last step I do is square. It's always going to be positive when I square something. I take this one. Let's not do it the formula way. Let's do it the other way. I want to write it as the same thing times itself. I know x squared is going to come from x times x. Minus 20x is going to come from x times the negative 10 and negative 10 times the x. I would get negative 10x minus 10x. That would give me my negative 20x. And then the last guy is going to come from last times last. Negative 10 times negative 10, which again always provides 100 because a negative times a negative. You'll get plus 100. So that is completing the square.